In this video, we're going to look at a certain type of function called a piecewise function. So a piecewise function is really exactly what it sounds like. It's different parts of a function put together. So what's going to happen is if you have a graph that's maybe like part of a parabola and part of a line, and you want to write it all together, you could write it as a piecewise function. So there's multiple different functions, or maybe 3 different types of lines put together to create this graph. And you would have to write the equation using piecewise notation. So the first thing we're going to look at is what a piecewise equation looks like, and then we'll actually look at the graphs of them. So in this example, you see this bracket here, and there's 2 different parts. So these are the 2 different pieces. So there's this part number 1, and there's this part number 2. And each piece contains a restriction or a condition that you have to follow. So what this means is if x is less than 0, we're going to use this first part. That's what the rule is we have to follow. If x is greater than or equal to 0, well then that means I have to plug into x minus 1. That's the rule, or that's the part of the function I want to use. So these right here are the conditions, and they tell us which piece to use. So you don't actually plug into those, you just read those, and those tell you what to plug into. So are we going to plug into this yellow part, or are we going to plug into this blue part right here? So that's what we're going to be plugging into. So we look at this first example. We look at what's our input. So in this case, our input is -4. So we ask ourselves, well, which category does -4 belong to? Does it belong to it's less than 0, or is it greater than or equal to 0? Well, -4 is less than 0, so that means I need to use number 1. I'm going to use equation number 1. So when I go to plug in, I'm going to have f of -4 equals, and I'm plugging right into this, into the yellow. So I'm choosing number 1 because -4 was less than 0. So I'm going to put my parentheses plus 1. My input is -4, so I go ahead and input that in. We end up with -4 squared is going to be 16. Remember to put that in parentheses if you're putting that in your calculator, because it's a negative times a negative. Plus 1 gives me 17. So there's the first one. Second one, the input is 0. So since the input is 0, that means we are going to plug into the second equation, because that's when x is greater than or equal to 0. In this case, it equals 0, so we're going to use number 2. So that's the one we plug into. So when we plug in, we have f of 0. So we have parentheses minus 1, input the 0. 0 minus 1 is -1. And we keep going here. So we look at the next one. The input is 4. So since we have 4 as our input, which category does that satisfy? 4 is greater than 0. So it's going to go in number 2. So we're going to use number 2. So we plug in. So number 2, so f of 4. And then we go ahead and write our template. So parentheses minus 1 is equation 2. My input is 4, so go ahead and input 4. 4 minus 1 is 3. So that's it. If you look at the next one, we have 3 parts now. So it's going to be the exact same thing. Here are our conditions right here. So we have x is less than 0. 0 and 2 are what x is bounded by. So x has to be greater than or equal to 0, or x is less than or equal to 2. And this last one, x is greater than 2. So those are our 3 conditions. Here's our formulas. So x plus 1 is one of them, 1, and -x plus 3. So those are our 3 parts. So part 1, part 2, and part 3. So 3 different types of equations to make up this piecewise. So we go ahead, we look at 4. 4 belongs to the third category. It's greater than 2. So that means we're going to use number 3. So when we go to plug in, so g of 4, negative, parentheses where the x is, plus 3. So our 4 gets inputted into the parentheses. So this ends up being negative 4 plus 3. So we get negative 1. Look at the next one here, 1.5. So 1.5 is between 0 and 2. So that means it's in category 2. So we're going to use equation number 2, or part number 2. And we go ahead and we set it up. And we copy this down, and wherever there's an x, we put parentheses, but there's no x, so there's no parentheses. So really what that means is there's nothing for us to plug into, so it's just going to equal 1. That's it. There's no x for me to plug 1.5 in. The second, or the third one here, negative 6 is less than 0, so when x is less than 0, that's true for negative 6. So for this one, we're going to use number 1. So g of negative 6 equals, we write our template. So our template is parentheses plus 1. Insert our input into that parentheses. So negative 6 plus 1 gives me negative 5. So if this is making sense to you, the graphing is basically the same idea. So let's do this last one here, and then we're going to look at some graphs. So 0, well, that's going to be this category number 2 because you have an equals 0. So this is when x is greater than or equal to 0 and less than or equal to 2. So for this one, you're going to use number 2, or part 2. So g of 0 is equal to, it's just going to be 1. There's nothing for us to plug into. So the last thing then is let's put these on a graph. So like I said, they're piecewise functions because there's different parts. So you might have different lines put together. You might have some parabolas or some cubic functions put with linear functions. So it's different parts all put together. So this first one you recognize from the first example we just saw. Now we're going to graph it. So I have my two conditions. That's going to tell me how I'm going to decide when to use which graph. So what I'm going to do is I'm going to start with function number 1. So function number 1 is going to be f of x equals x squared plus 1. And I'm only going to use this when x is less than or equal to 0. So that, or excuse me, when x is less than 0, not equal to it, just less than 0. So what that means is when I start my table for my graph, I need to start at 0. I'm going to put an open circle at 0 though, because I don't want to include 0, but I want to go all the way close to 0. So that means I'm going to put an open circle. And then I need all the x values that are less than 0. So negative 1, negative 2, negative 3, and so on. So we'll start with that and we'll see if that looks like enough. So now to get the y values, all we have to do is plug these into our function. So like what we did on the previous page. So if I plug in 0, 0 squared plus 1 is going to give me 1. Negative 1 squared, be careful with that, it's got to be in parentheses. So negative 1 times negative 1 is 1, plus 1 is 2. Negative 2 squared is negative 2 times negative 2, which is 4, plus 1 gives me 5. Negative 3 will give me 10. So basically, let me just make a note here. To get y values, plug x values into equation. That's all I did. So now that we have all of this, well, now we can graph it. So remember, I put that little open circle there to remind me that when I actually go to plot this, 0, 1, I'm going to have an open circle because I don't want to include x equals 0. It's x is less than 0. Negative 1, 2 is going to be a filled in circle though because that's included. Negative 2, 5. Negative 3, 10. All included. So now I'm going to go ahead and connect those. And I'm only connecting to the left because only the values less than 0 are included for this. So there's the blue one. There's the first one. The second part, we're going to do the exact same way. So we're going to graph f of x equals x minus 1 when x is greater than or equal to 0. So that means when I do my table, my starting point is going to be 0 again, but I'm going to have a filled in circle there because I can equal 0. And then I need all the numbers bigger than 0. So 1, 2, 3, and so on. There's not really like a required number of points. You just want your picture to basically cover your entire graph. So once you get the pattern too, you might not actually have to do the table of values, but it never hurts to do more values than not enough. So if you're not sure, just do some extra. It won't hurt you. So for these, I plug in, so 0 minus 1, negative 1. I'm just plugging these right in. 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2, and so on. So I could do more, but this is enough for now. So then I go ahead, 0, negative 1. That's going to be filled in this time because it includes it. 1, 0, still filled in. 2, 1. 3, 2. You can kind of see your pattern here. The slope is up 1 over 1. So you could plot more if you want. Or at this point, just take a straight edge or a ruler. And when you connect, here's what you have to be careful of. Your arrow should only be going to the right. It should not be going to the left because you are only including the values as x is greater than 0. So you could plot more points, or you could just know, I just need to make my arrow go to the right. The left is done because this was our starting point. So this right here, to just finish it up, this is the function f of x. Two different parts. You can't write it as one equation. That's why we have to use a piecewise. So this is the same thing we saw on the previous page. So you could graph it, and I could say evaluate when f is negative 4. Well, you would go to your graph, and you would look at when f is negative 4, and then you would tell me the y value that's associated with it. So you could use the graph to evaluate as well as what we did on the previous page. Let's look at the last one here with 3 parts. So the 3 parts, again, no big deal. It just means that when we graph, we're going to graph 3 different equations. So I'm going to use 3 different colors because I like to color code. So here's my first part. Here's my second condition. And my third condition. So for the first part here, f of x is equal to x plus 1. I'm going to use that whenever I have x is less than 0. So I'm going to start at 0. It's going to be an open circle. And I want some negative values. So negative 1, negative 2, negative 3, and so on. I'm going to plug in. So 0 plus 1, negative 1 plus 1, negative 2 plus 1, negative 3 plus 1. Go ahead and plot them. So 0, 1, I'm going to have an open circle. Negative 1, 0 is going to be filled in. Negative 2, negative 1, filled in. Negative 3, negative 2. And I could keep going with my slope here. Or again, take and draw my line. And when I draw my line, remember, it should be going to the left this time. The left because I'm including when x is less than 0. So now we move on to number 2. Number 2, my function is f of x equals 1. So this is between 0 and 2. So for this one, in your table, you have endpoints. You want to start at 0, filled in because it has the equals bar. And you want to end at 2, filled in because, again, it has the equals bar. If this didn't have the equals, if it was just, let's say, x is greater than or equal to 0, but then x is strictly less than 2, in that case, you would have open here but closed at 0. So that can happen. And then I just fill in any points between, which in this case is just 1. So then for this, when I plug into the function 0, 1, and 2, there's nothing for me to plug into. The y value is just going to stay at 1. So this is just going to be a horizontal line. So if I go to 0, 1, that's going to be filled in. This looks like this shifted a little bit on me. So this circle should now be filled in, 0, 1. And 1, 1 is our next one. And 2, 1. So I think my graph shifted, but this 0, 1 from the first one that was an open circle is now filled in. So that means um, it is now considered closed in. So it's now not empty anymore. It's part of the function. I'm just going to try to move these points back just a little here. All right, so I cleaned that up a little bit. So now I'm going to look at the last one here. Because my graph shifted. So now we're looking like this. Everything's filled in. Last one here, f of x equals negative x plus 3. Again, start with my table. Starting at 2, and I'm going to have an open circle at 2. Want all the numbers bigger than 2. So 3, 4, 5, and so on. The dot, dot, dots also help me remember that there's going to be an arrow there. So now I'm going to plug in. So you plug in 2, you're going to get 1. Plug in 0 into this equation, it's 3. Plug in 4, you're going to get negative 1, then negative 2, and so on. So I have 2 comma 1. Notice it's overlapping. 3 comma 3. I have 4 negative 1. Oops, I plotted something wrong here. Wrote the wrong thing here. Sorry about that. This should be 3 comma 0. Something didn't seem right. My line shouldn't be going up and then down. So 2 comma 1, 3 comma 0, 4 negative 1, 5 negative 2. And then when I go to connect these are all going to be continuing going till the right. Because remember, it's when x is greater than 2. So all the numbers to the right are going to be included as well. So this is called our function f of x. I'm going to just label that in the corner. And the only other thing I want to do is just talk about real quick. These are both functions. They have to be in order to say it's a piecewise function. But the difference in the graphs, this one is considered continuous because see how if I were to put my pen on here, I could just trace the whole thing and I wouldn't ever have to pick up my pen. So this is considered a continuous function. So I just want to add that as a vocab because there's no jumps versus the first one was not continuous. And we'll talk more about that later on as the semester continues. But this one is not continuous. This is a jump discontinuity because you can actually see the jump in the function. So if you start with the blue, you trace it, you have to literally pick up your pen or pencil to jump and then trace the red. So this is considered a non-continuous or not continuous function, and it has what's called jump discontinuity. So, and we'll talk about that later, but for now I just wanted to get that idea in your head. So that's it for this one, and then we'll continue talking about in class when I see you. We'll actually continue talking about the next section there with doing some algebra with functions and compositions, looking at some business applications, and then equations of lines. So I will see you in class next time.